All right, let's just jump right in. If you've ever tried to use an AI coding assistant on a huge, sprawling code base, you know the struggle is real. Well, today, we're going to look at a tool that's built to tackle that exact headache. It's part of this cool new wave of what you could call RAG for code, and its name is Context Plus. I mean, you've been there, right? You give your AI a pretty clear task, something it should be able to crush, but because your project is just massive, it gets totally lost. It starts reading the wrong file, maybe hallucinates a function that doesn't exist, or it just completely misses a super important dependency, and you're left doing all the tedious navigation work for it. You know, this quote from the source article it hits the nail on the head. It perfectly describes the problem. The AI has the logic down pat, it knows what to do, but the sheer size of the codebase turns its work into a complete guessing game. It's kind of like having a world-class surgeon who can't even find the operating room. So how do you fix that? Well, you give the surgeon a map, and that's exactly where Contacts Plus comes in. It's designed to automate that entire navigation layer so your AI can finally stop guessing and start executing with some serious precision. Now, what's really important to get here is that Context Plus isn't some new AI model. Think of it more like an indexing engine. It scans your entire project, every symbol, every call site, all the relationships between files, and it builds this super detailed map. So when your AI needs to find something, it doesn't just start reading files at random, it just asks the map. And it does all this by being an MCP, or Model Context Protocol Server. You can basically think of MCP as a plugin system for large language models. It's a little background tool that gives your AI extra powers and a deep understanding of external info. And in this case, that info is the complete structure of your code. Okay, so how in the world does it build this incredibly detailed map? It's not magic, I promise. It's actually a really smart combination of three powerful layers, all working together to create that deep structural understanding of your code. So first up, it uses TreeSitter. This thing builds what's called an abstract syntax tree, or an AST, for every single file. This is so key. It's not just doing a simple text search. No, it understands the actual grammar of your code, whether that's TypeScript, Python, Rust, or Go. It knows exactly what a function is, what a class is, and precisely where it lives. No more guesswork. Next, to make the search truly semantic, based on meaning, it takes all those code symbols and signatures and uses a local Llama model to turn them into embeddings. These are basically just numerical versions of your code that let the AI search for what a function does, not just the exact keywords you use to name it. And the third layer is spectral clustering, which is just incredibly cool. It looks at all those embeddings and automatically groups files together that are conceptually related. So instead of having to navigate a rigid folder structure, you can actually explore your code by features like authentication or payment processing. It's just a much more natural way to get your head around a complex project. Okay, so now we have this powerful index sitting there. What can your AI actually do with it? Well, this is where the theory gets real. Context Plus gives your coding assistant a whole new set of tools that completely level up what it's capable of. These tools basically fall into four main buckets. You've got discovery, so you can find code just by describing it. Analysis, to figure out the full impact of a change before you make it. Code ops, which gives you a safer, AI-friendly undo system. And memory, which lets you build up a persistent knowledge base about your project that doesn't disappear when you close the chat. But listen, if there's one feature here that makes the whole setup worth it, it's gotta be get blast radius. You just give it a function name, and bam, it instantly tells you every single place in the codebase that imports it or calls it. This completely gets rid of that classic developer nightmare, where you change one tiny thing and accidentally break 10 other things you had no idea were even connected. It's a total game changer. So let's imagine a real-world task, like refactoring your auth middleware. Instead of digging around for files, the AI just runs a semantic search for authentication and immediately finds the right two files. Then it checks the blast radius for the main token validation function and sees, okay, there are 7 dependencies. It can even get a summary of a file's API before reading the code, and then it can make all its changes safely. The difference is just night and day. And that proposed commit tool is really worth pointing out too. It creates what the project calls shadow restore points. So before the AI saves any change, it just takes a quick snapshot of how the file looks right now. If the edit turns out to be a bad idea, you can instantly roll it back. It's like an undo button made specifically for the AI, a safety net that doesn't clutter up your Git history.
Okay, this all sounds pretty amazing, right? But what does it actually take to get it up and running? And, what are the catches? Let's talk about the practical side of things for a minute. The setup is actually, and I was surprised by this, refreshingly simple. First, you just need to have a llama running on your machine with an embedding model. The docs suggest using nomic embed text. Then second, you just add the context plus server info into your mcp.json file, which is the standard config file for these kinds of tools. And that's it. You're good to go. Now, let's be real about the limitations. It does have a hard dependency on a local Llama instance, so you have to have that running. Also, the index isn't live. You have to manually refresh it after you, say, merge a big branch, so you have to remember to run that command. The memory graph also needs some manual care and feeding from you, the developer, and if you're working in a huge monorepo, you might have to do a little extra configuration for each service. So, the million-dollar question, is it worth it? Should you actually use this? The source gives some pretty clear advice here. For smaller projects, maybe under 15,000 lines of code, your AI can probably handle things just fine without it. But once you cross that 30,000 line mark, yeah, absolutely. The time you'll save just from the blast radius analysis alone makes it a total no-brainer. And that really leaves us with one final thought. By giving our AI assistants a perfect, high-fidelity map of our code, we're taking away one of the biggest roadblocks to making them truly useful. So the real question isn't just about fixing annoying mistakes. It's about what new, ambitious things you could finally build if your AI partner never got lost again.